Hi, I'm Miss Hearn. Let's get started. In this video, we're going to talk about different types of positional number systems, starting with our own. We work with the base 10 number system. And sometimes we like to write our base 10 numbers, like the number 253, in what we call expanded form. To understand expanded form, I want you to think about a cash drawer, like you would see in the grocery store, except in this cash drawer, instead of having the usual denominations, $1, $5, $10, $20, all of our dollar bills are going to be in denominations that are powers of 10. 1, 10, 100, 1,000, 10,000. So let's say that we're working with this cash drawer and we want to give someone $253 in change. We like to do this using the fewest number of bills possible. So think about how many $10,000 bills we would have. We're not going to use any $10,000 bills because that would be more than $253. To indicate that, I'm going to put a little zero next to the thing that on the little line next to times 10,000. We're having no times 10,000. And we're not going to give them a $1,000 bill either, so I'm going to put a zero next to the $1,000. However, I could give them $100 bills. In fact, I could give them two $100 bills. 2 times 100 means I'm actually giving them $200. How much do I have left to give them at this point? Well, 253 minus 200 leaves $53 that I need to give them. I can't give them another 100 because there's not 100 left, so I have to move on to the tens. How many tens fit into 53? Well, 5 of them, right? 5 times 10 is 50. So out of the $53 left to give them, we've now given them 50, leaving 3, so we need 3 $1 bills. This is what we call the expanded form of the number 253. We usually would just write this part. There's no need to put the zeros at the beginning. And the two different types of numbers that we see here are what we call the face value, the 2, the 5, and the 3, and then the place values, which in our number system are all powers of 10s. So the face values indicate the number of bills of a certain denomination. For example, the face value 2 means we have 2 $100 bills. The face value 5 means we have 5 $10 bills. And the face value 3 means we have 3 $1 bills. Now, when I actually write the number 253, I don't have to write the 100, the 10, and the 1 because the position of the number tells me which denomination that I'm talking about. This is why it's called a positional number system. Also, our bases are always powers of 10 because we're using a base 10 system. So the place values correspond to the denominations, the types of bills that we have in the drawer. Whereas the face values are the number of that type of bill we have to give. So that's how it works. That's how our base 10 number system can be written in expanded form. Let's talk about a base 6 number system. So this image would be for a base 6 number system. By the way, all of the values are powers of 6. 6 to the 0 would give us the $1 bill. 6 to the first would give us the $6 bill. 6 to the second would give us 36. 6 cubed would give us 216. 6 to the fourth would give us 1,296. In a base 6 system, these values are our denominations. Now, let's say that we had to give someone 253 base $6. The face values in the 253 base 6 indicate the number of bills of each type that are required. Now remember, the position tells us which bill we're talking about. The 3 is in the farthest position to the right, so it's going to correspond to the $1 bills. The 5 is in the next position over, so it's going to correspond to the $6 bills. And then the 2 is the next position over from that, so that's going to be the $36 bills. We don't have a 4th and 5th digit, so we are not going to use these bills. Let's go ahead and place the face values in the appropriate blanks. So for 1, we have 3. For the $6 bills, there are going to be 5 of those. For the $36 bills, there's going to be 2 of those. And we don't have any $216 bills or $1,296 bills. All right, let's go ahead and figure out how much change we're giving them in actual base 10 numbers now. So we are going to perform these operations. Let's see what we get. So 2 times 36 is actually $72, plus 5 times 6 is actually $30, and then 3 times 1 is $3. And let's see, if we add these up, we're going to get $105. Now this is actually in base 10, our usual number system. So $253 in base 6 sounds like a lot, but actually it's only $105 in our base 10 number system. Primarily because instead of having bills with denominations 1, 10, 100, we have only 1, 6, and 36. So the powers of 6 are smaller than the powers of 10. So we end up with, even though we have the same number of bills, we end up with a different value. So now we're going to use this idea to help us to convert between base 10 and base 6. When you're working on this yourself, you're going to draw your own little cash drawer. And I have started it for us here in example 2. It says create your own base 6 cash drawer by completing the given table of values. Always start farthest to the right, which isn't what we're used to. We usually write left to right, but we're going to write right to left. Always starting with the power of 0 first. Notice that this is a power of 0, which, by the way, any number to the 0 power is 1. So the first bill in the drawer, farthest to the right, will always have a denomination of 1. 6 to the first is 6. 6 squared is 36. 6 to the third power, if you multiply 36 times 6, you're going to get 216. 6 to the fourth is just 216 times 6, so that's going to give you 1296. One more factor of 6 will bring us to 6 to the fifth is 7776. Okay, so this is our cash drawer. Picture the actual bills like we had up here in your mind, right? We're just writing the values of the bills so that we can keep track. Now we're going to use this to write the expanded form of each number, always working from right to left. Remember that the face value indicates the number of bills of each denomination. We're going to have 3 bills times whatever this value is for those bills, plus we're going to have 4 bills times whatever value this is, plus we're going to have 1 bill times whatever this is. Now we always start farthest to the right. This is going to be a place value of 1. So this is 6. So this is 36. So now we just need to do our arithmetic. So let's see. 3 times 36 is 108. Remember, multiplication comes before addition. So we're going to do all the multiplying first. So we have 108 plus 24 plus 1. So adding that up, we're going to have a total of 133. Now this is how much 341 base 6 is, but in our regular decimal system that we're used to, it's 133. Again, it's going to have a smaller value than we might think because we're used to having denominations or place values that are powers of 10 that are much bigger. All right, let's convert 10 base 6 now. So this is only going to have two place values. So we're going to have 1 times whatever its place value is. Remember, the 1 is called the face value. And 0, another face value, times whatever its place value is. Face value, place value. We do this over and over again. Face value times place value. As far as filling in the place values, remember again, we always start farthest to the right. So I am going to start with always a 1 here. And then this one is just 1 over from that, which is 6, and we're done because we only have a 2-digit number. So we're going to get 1 times 6 is 6, plus 0 times 1 is 0, so we get 6 in base 10. Now this shouldn't be a surprise because in a previous lesson we talked about how in base 6 there is no digit for 6, 5 is the largest digit, so you have to roll over to 1 0 to represent a 6. In fact, in any base, the base is always represented by 1 0, just like in our number system. Okay, anyway, moving on then, we have a nice long number here. So let's see what we got. We're going to have 1 times something plus 0 times something plus 2 times something plus 0 times something plus 3 times something plus 0 times something. Okay, so what are the somethings going to be? We're going to get them from our cash drawer values, our powers of 6. Always starting with a 1, then we're going to have our 6, then we're going to have our 36, 216, 1296, and 7776. Now, if we had more digits, we'd have to even go to higher powers of 6, but we're good here. All right, so let's do our arithmetic. So this guy is 1 times 7776 is 7776. Don't have to worry about the 0, goes away. 2 times 216 is going to be 432. We're going to erase this one, that's just 0. 3 times 6 is 18, and then we're done. So we're going to add these up. So we have 7776 plus 432 plus 18, and that's going to be 8226. So remember, the number looked like it was bigger than 100,000 in base 6, but when we convert it to our number system and see what it's actually worth, it's only 8,226. I hope you found this video helpful. If you did, please give it a thumbs up. That will help other students to find the video. You can also subscribe to my channel, Miss Hearn Mathematics, for more math videos.